In this problem, we are again going to be using the double angle formula for sine. If you consider this question, we've got 4 sine squared x on 2 times cos squared x on dx. You can see there is a similarity with the double angle formula for sine. What we have is the integral of 2 sine x on 2 times cos x on 2 all squared dx. If you compare that to the general double angle formula, you can see there is a great deal of similarity. In this case, what we have is A is equal to 1/2. So what does that mean? It means 2 squared is 4, so I have 4 times sine x on 2 cos x on 2 all squared dx. I'm now going to use the formula where a is equal to 1/2. If a was equal to 1/2, what I get is sine 1/2 x times cos 1/2 x equals 1/2 sine. 2 times 1/2 is 1, so 1x. So in other words, sine of x on 2 times cos of x on 2 is equal to 1/2 sine x. That is what we have in the bracket. So we're now going to replace sine x on 2 times cos x on 2 with 1/2 sine x. Remember, it is still all squared dx. What we now get is 4 times 1/2 squared is 1/4 sine squared x dx. Tidying that up, we get sine squared x dx. Now, using our double angle formulas again, we know that sine squared x is equal to 1/2 times 1 minus cos 2x. This is the question we solved in part A. So I'm going to replace sine squared x with 1/2 1 minus cos 2x dx. I'm going to take the 1/2 outside the integral sign, leaving me with 1 minus cos 2x. And then I'm going to anti-differentiate. So I'm going to have 1/2 times x minus 1/2 sine 2x plus c, multiplying through by the half, x over 2 minus 1/4 sine 2x plus c.